Unit vectors. Let's start by reviewing a few properties of similar triangles. So suppose you have a little triangle like this one here on the left, and it's got length here A, and height here B, and hypotenuse here C. Well, these two triangles would be similar if this other triangle here is just a scaled up version of the smaller one. So if this side over here is a multiple of A, say K times A, and all the other sides are also multiples of the corresponding sides of the smaller triangle, say K times B and K times C, notice that it's always the same multiple, then we say that these two triangles are similar. What's important about similar triangles is it preserves the orientation of this line here. So this angle here and this angle here are the same. Now suppose you're given a vector with components 3 and 4 over here, and using Pythagoras you can find that this hypotenuse here has a length of 5 units. This is a 3, 4, 5 triangle. It's a Pythagorean triple. And the question is, how can I find some vector that is oriented at the same angle as this one over here, but that's a unit vector with respect to this unit here, to this vector here? Well, we're going to just basically use similar triangles. We're going to find a triangle that's similar to this one here because it preserves the angle, but I need this to be equal to 1. So let's scale down this triangle by a factor of 1/5 everywhere. So if I divide everything by 5, like this, then I get 1 as a hypotenuse, 4 over 5 over here, and 3 over 5 over here. Now if I try to use the magnitude formula to find out what the magnitude of this vector would be, I would do 4 over 5 squared plus 3 over 5 squared, and then square root. And if you do that, you'll see it's 1. It gives you 1. And that's exactly what we want. It gives us a magnitude of 1. Unit vectors have magnitudes of 1. And we've preserved the angle over here. So essentially what we've just done is we've taken this vector, and we can do this for any vector. We've taken this vector over here, and we found its unit vector. This is equivalent to taking the vector, let's say this is vector u. It's equivalent to taking the vector u and dividing it by its magnitude.